Alright, so here in lesson 5, I want to talk about the intermediate value theorem, and this is kind of a theorem that's it's just kind of, once you see it and understand it, it's just kind of like, well, duh, that's obvious, alright? And it is kind of an obvious thing once you understand what it's saying, okay? So I want to look at this graph first of all. This will be some good practice for us, graphing a little bit of trig and also graphing a piecewise function. Okay, so you see here it says that f of x is tangent of pi x over 4 when the absolute value of x is between or is less than 1. Okay, that's just another way of saying when x is between -1 and 1. Alright, if it helps you to rewrite it that way, go ahead and do it. Okay? So, we also have here that f of x equals x when the absolute value of x is greater than or equal to 1. Or in other words, when x is greater than or equal to 1, or when x is less than or equal to -1. Okay? So at that point, I know I'm on the line y equals x. Let's graph that part first, because that's the easy one. Okay? We have the line y equals x. It's going to hit the point 1, 1, and it's going to continue to go forever this direction. There's the part where x is greater than or equal to 1. When x is equal to -1, we're at -1. And it's going to go this way forever. So now we've got the tangent that we need to work with, okay? So graphing the tangent, you guys know that it starts at the origin, and that first period is kind of centered at the origin as long as it's not moved horizontally, and this one's not. What does this pi over 4 inside the tangent do? What kind of a transformation is this?
Was that like the scalar virus multiplication?
We are multiplying it by the x by a scalar, so what does that do? How? Horizontally, okay? So it's going to impact the period, okay? The period of tangent is typically what? Pi, okay? It has asymptotes at -pi/2 to pi/2, okay? So it's approximately pi. All right. Now, we got to figure out what this is going to look like. So the period for tangent of pi x over 4, if you remember, the period is the usual period, which in this case is pi, divided by the b. The b was that thing that's multiplied by the x. Okay? So this is pi divided by pi over 4. Which just equals 4. Okay? So I know the asymptotes are where? At -2 and 2. Alright? So they're going to be like over to the left and over to the right at -2 and 2. So I don't need to draw necessarily those asymptotes because they're not going to be part of our graph, because by the time I get over to -2 and +2, I'm already on the other piece of the piecewise function.
Wait, how do you know it's -2 and 2?
Yeah. Because tangent is it's centered at 0, okay, and the first period is symmetrical. Tangent is an odd function, remember? So it's symmetrical about the origin. If I flipped it 180 degrees, it would be identical to itself. Okay.
How do you know the function is a straight line?
Well, that's the other part. That's this part here.
And the blue one.
Okay? The blue one is going to be our tangent. Now, I want to see where the ends are, since I know there's not an asymptote I need to worry about in here. Where are the ends going to be? So let's try when x equals 1. If x equals 1, tangent of pi x over 4 equals what?
When x equals 1, it's 0, isn't it?
But it can't be.
No?
It's
pi over 4 is 1.
It's 1, because it's tangent of pi over 4. If x equals 1, it's tangent of pi over 4, which equals 1 from the unit circle. So actually, look, we've got an open point right there at 1, 1. Now the line fills it, but that's actually a good thing, because look, now I know, as I'm drawing this, I know this is going to be continuous. With piecewise functions, that's the point that you really got to be concerned with when you're talking about continuous. Because that's where, you know, tangent could be going up here and the line is down here and you have a discontinuity. But if they meet, then, you know, it's continuous there at least.
Why did it occur?
Because this is tangent, all right? So when x is negative 1, what is tangent of pi x over 4? It's negative 1, okay? Tangent of a negative pi over 4 is negative 1. So again, we have this open point. Here's the other part of our tangent. Or you could have used the symmetry that's in our tangent function to figure that out too. But that's what this whole thing looks like, okay? Kind of
Why is it open? We cannot equal one?
well, with this piece it can't, but then the line fills it up. So it is continuous there. All right. Any questions so far?
Can you explain
Misha?
again the red part, why it also goes like down?
Because its absolute value is greater than or equal to 1. So that means it's either greater than or equal to 1 or less than or equal to negative 1. So it gives us this side and this side. Okay? All right, so how are we going to use that? Well, we're actually going to illustrate our intermediate value theorem using this function in a little bit. Okay? So let's look at what the intermediate value theorem is actually saying. All right? It says here, if f is continuous on the closed interval from a to b. All right, so in our diagram, we have this interval from a to b. By the way, remember we said this is why we learn how to make something continuous on a closed interval. All right? So it's continuous from a to b. And k is any number between f of a and f of b. So you have your two y coordinates for the left side and the right side.
Do we include A and B? Are we including A and B or any?
Yes, closed interval. So we are including a and b. So we pick some random number k between f of a and f of b. Then, this is what it's saying. There is at least one number c in the closed interval from a to b such that f of c equals k.
And there's maximum 3, right?
Actually, it's possible to have an infinite number depending. Okay, in this case there happens to be 3. Alright, so illustrating here, we have this value k. And basically we go across and we know that because we're traveling from f of a down to f of b, and it's continuous, we know we have to cross this horizontal line at k somewhere, right? The only way we could miss that horizontal line is if it were not continuous and we jumped over it, all right? That's why I said this is kind of like one of those duh theorems once you understand it. The only way to get from f of a to f of b is to pass through k somewhere. That's why it says at least one time. Okay? Now, what we're looking for, this proves the existence of at least one value c. C is the x-coordinate that will give us k. Alright, so let's look at this actually in an actual function that we just graphed. If you're paying attention to your notes, this was the one that we just graphed. It was already in your notes, just down the page. But notice what I did here. I gave you an interval. The interval from A to B is the closed interval from 8 to 30. Okay?
Just like randomly chosen?
Yeah. You can pick, as long as it's continuous on that interval, I can use that. Alright? So f of A, which is f of 8, equals 8 in this case. And f of 30 is 30. Okay? So that's what I've done over here. So now I picked a random number 9.4. It's between 8 and 30. And I have one error I want to make sure I fix. I should not have labeled this k down here, because k is the y coordinate.
So it should be 9.4.
Okay? K is 9.4 right here.
Yeah.
So what the intermediate value theorem proves is that there is a value c down here. I should have labeled this c to match our theorem instead of k. Alright? So that's the c that we're looking for. Well, what does c equal in this case? 9.4. Okay? Let's do a second example just to kind of drive this home even more. Let's say that we are somewhere let's say we're at negative I want to make one that kind of works nicely. Alright, to negative. Let's say our closed interval goes from negative 10 to, let's see, pi over 6. Negative pi over 6. Okay? Alright, so there's our closed interval. Negative pi over 6, 3.14 divided by 6 is somewhere around a half. A little bit less than a half. Okay? So there's our closed interval. Someone give me a number between negative pi over 6 and negative 10. Negative 7. Okay, I heard that. So, or I'm sorry, we don't care about a number between negative pi over 6 and negative 10. What do we want between?
The y value?
The y values, okay? So, what is f of negative 10? Negative 10, okay? What is f of a negative pi over 6?
So should it equal to, so the x value should equal to the y value, or just how your function is?
Well, on this part of the function, the x equals the y. But at negative pi over 6, we're on this tangent part, right?
Negative tangent of pi over 6. Which
Well,
is
it's tangent of,
pi over 6, which is 1/3. I don't know.
it's that. Don't forget the pi over 4 times the x in your function, right? The function had that tangent of pi over 4 times x. And this did not turn out really nicely at all, but that's okay. You can handle it. Alright, so someone grab your calculator. And what is the tangent of pi over 4 times pi over 6? Alright, good. It's 0.436. If we go three decimals like we do in AP Calc. Alright, so let's illustrate that then like we did the other one, okay? We have the 0.436 right here, and we have negative 10 right here, okay? So, you guys had said before you wanted to pick the number -7. So let's make k equal to -7. This proves that we can find a value of c. Notice c does fall within the range from -pi/6 to -10. Okay?
But can K be any number or not?
K can be any number between -4.436 and -10. It's got to be within this range of y values.
Oh, they have to.
Yes.
So they don't
That's
care,
why it's called an intermediate value. That means in the middle.
Okay.
so they don't care about K, whatever K you want.
K is whatever we want as long as it's in here.
This is asking
It's
for
between,
Okay.
then we should find the x value that we would equal -7.
Okay?
wait, it that should be 0.346 or negative 0.
Yeah, is it positive or negative?
Yeah. The usual
What do you
is
mean?
negative.
You drew it positive, but then you wrote it the
No,
tangent.
No, it's
You
negative.
drew it negative but wrote.
But you wrote it positive.
No, that's negative.
No, that one.
Oh, there. Okay. Sorry, yeah.
Shows this number. Yeah,
Sorry.
it shows that
Yeah, that's negative.
between 8.
Okay, so guys, what is the C then? What is the value of C that we're looking for here?
-7.
It's -7, okay? I look at my function, guys,
Stop.
I look at my function here, and I say, okay, where does y equal -7? I'm past the part where the tangent is, so I'm on that line y equals x, so it is just a -7. C equals -7 in that case, okay?
So, if we're gonna be asked to find a C or a K, we're gonna have another value.
You'd be asked to find the value that the intermediate value theorem guarantees for a certain value of k, something like
Okay,
that.
so,
We might give you the value of k,
and
You
we
know.
have to find the C, and we're gonna have the function. I mean,
yeah, you would have the function,
okay,
otherwise
so,
we don't know what to plug it
I
into.
mean, that's easy.
Okay? Magical?
So if you, the K number is -6, if I give like K equal -5, and that means C also equal -5.
In this case it does, yeah. Because at -5, I would be over here on this portion of the function, and that's the portion that's where y equals x. Okay? So yeah. Yes.
But if I have like 0.5 in the graph, okay.
That's a good question. If you have 0.5, -0.5, let's say you made k, we'll make that k1, and that'll be c1. Let's say we had a second value of k that was a -0.5. That's a great question. Well, you would come over here and you would see, oh wait, we are on the tangent portion of that. Okay, so I would come up here, this would be my C2, and down here I would have to say, okay, well C2, I'd have to do a little bit of algebra, right? Because f of C2 would equal a -0.5. So that means tangent of pi/4 times C2 equals a -0.5. So I'd have to do an inverse tangent and then multiply by 4/pi, and I could get my C2. Alright? You would have to just do the algebra here to solve to get C2. Okay, so the question is, what good is this? It is kind of an obvious theorem, But one of the uses for this theorem is actually to prove that we're going to have a zero somewhere. Okay? For example, if f of A is a -2 and f of B is a +1, then I know somewhere between -2 and 1 there should be a 0. Okay? I know there will be a y value. If my y value on one side is negative and my y value on the other side of the interval is positive, I know I've got at least one 0 in that interval. Okay? That's a primary use of this theorem. Okay? So that's really everything that we need to know about this intermediate value theorem. It's a relatively simple theorem, but it just depends on the function you're using. Sometimes it can get complex.
So